keeps making all kind of shapes and noises. Okay, where I started. That goes down, that goes away. And well, before we do that, what I mean by learning the identities. Well, there's this thing called the unit circle. Okay. But it's not what I want. And a lot of people try to memorize the unit circle. Well, you don't have to memorize the unit circle. Why? Right now you've got to memorize how to use this thing. You don't memorize the unit circle, you learn it. There's a difference between learning and regurgitating. Regurgitating, you don't learn anything. You end up being a cash register person that can't make exchange for 6 cents, $11.56, give them $20.06, watch a head explode. That's the kind of person you turn into. You think about that. So, if you try to learn the material instead of regurgitate it, it helps. And with the unit circle, all you've got to remember is 3 things. One is the 30-degree circle, 30-degree triangle, the 45-degree triangle, and the what? 60-degree triangle. All right, learn these back in Trig. And of course, the easy one to remember is 1, 1, square root of 2. And that's the 45-degree triangle. And what's this one? What's the 30-degree? Well, you only got to remember one thing, and that's the hypotenuse is the what? Longest side, Hubert. That's right. So, what's greater, the square root of 2 or the square root of 3? Do y'all have any idea what I'm talking about? Yes? No? Okay, well, speak. Just, your mouth, you speak. What is it? The square root of 3. So which one is it? What's this side? This side is the second to the longest side. This is the shortest side. So what is this? Well, y'all not working on me here. I put numbers here. So that means I'm going to put numbers here too. What are the numbers? Y'all are scaring me. Yeah, that's one of them. I mentioned that one, yeah. Okay, where does the 1 go? Okay, where does the 2 go? On the bottom. And where does the 3 go? Wait a minute. Square root of 3. That's square root of 3. This is 2. 2 is larger than the square root of 3. Let's see if this works today. Yesterday it worked. Oh, man. We got an eraser. Square root of 3. Right? Y'all do remember these, right? Well, then say something. Don't just sit there like I ain't going to say on bull. But anyway, y'all have no idea what I'm talking about anyway. Square root of 3, 2. And that's your 60. Now, you also have to remember how to change pi over 180 and 180 over pi. That's all you got to remember. Because this is 0 and 360. Then this is what? This is, and this is. Okay, thank you, class. Now, put the 30-degree in here. 30 degrees, or, well, 30 degrees, I want to change it into, so that'd be 30 pi, that'd be 3 pi over what? Pi over 6. $45 degrees. 45 degrees, 45 over 180 would be what? and 60 degrees. 60 degrees would be 60 over 180, which would be pi over what? Pi over what? Now, what's 180 minus 30? Okay. What's 180 minus 45? And what's 135 minus 60? I'm sorry, 180 minus 60. Now change those right quick. So, whoever this teacher is in your past that told you had to memorize the unit circle, you didn't get your money's worth. Because you don't have to memorize it. You just have to learn these three things right here. Well, let's keep on going. I'm not going to change these. I'm going to let you change those, okay? Well, what's 180 plus 30? What's 180 plus 45? My ear just did something weird. Had a ring and then it stopped. Oh well. And what's 180 plus 60? 240 for that person, one person mumbling. I heard that. I think I heard 240. Really, I heard. But one person mumbling is better than 20 people on a bull, blank on a bull. And what's 270? And you can do this either way. What's 360 minus 30? What's 360 minus 45? Hey, there we go. I think we're getting a little bit of participation, I believe we call it. And what's 360 minus, I'll do this one for you, 300. Now change those into pies right quick, and you've just completed your unit circle. Isn't that great? You don't have to memorize it. Now, I don't know who I'm talking to. There's two types of people in here. There's the person that invented the unit circle, okay? Whoever you think you are in here, all right? And then there's the person that never could memorize the unit circle. Hopefully I've helped you out. Because now all you have to do is put the cosines and the sines. We'll do those eventually, okay? Actually, you still just memorize these. Okay? That's the opposite. That's the opposite. That's the opposite. That's the hypotenuse. I'm sorry. That's the hypotenuse. That's the adjacent. Hypotenuse, adjacent. Hypotenuse and adjacent. And just remember, on the unit circle, it's not sine cosine, it's what? Two people, thank you, out of 21. Okay, so cosine, sine. And of course, you can actually think of this as a special angle of, 1 to the right, 0 height. So think about that when you're doing that. It should be easy for you. The rest of them you can just fill out. So to answer your question on identities, is there a trick? The only trick that I can tell you is the same trick that I tell students with the unit circle. Learn it, don't memorize it. Because if you memorize it, it's easier to lose. Okay? So all you have to memorize is the special angles. Those 3 special angles right there give you everything you need as far as trig, the unit circle and everything, those 3 special angles. Now, what really concerns me is when I put the 3 special angles up there, I didn't have 21 people telling me to fill the numbers out. That's concerning. Either you don't want to interact with me or you didn't know it, one of the two. So you need to work on both of them. All right. So that's That's your trick. Now, how do you use that trick? Well, you use it by learning these basic ones. And yes, if you want to call it memorizing, then yes, you need to memorize these basics. If you've never memorized these basics, then that's probably why you've always had trouble with, and where is my, oh, I didn't save it. Hold on a second. I suck, I know. Back here, save. I thought I saved it as identity. Did I not? Let me make sure it goes in pictures. Identity. There. Output. So make sure you learn these. All right. Now, we can take, let's take sine squared plus cosine squared is equal to 1. Something pretty basic. Why did I start with that? Anybody want to take a guess why I start with that one? Because it's a Pythagorean identity, and unless you've been non-sentient since pre-algebra, the Pythagorean theorem is a squared plus b squared is equal to c squared, right? Yes, Hubert. That's right. Thank you. Oh my! No wonder y'all have sucky teachers. You don't interact with them. All right. So sine squared theta plus cosine squared theta is equal to 1. Now I want you to rewrite that, but don't use sine and cosine. You can use sine and cosine. I'm sorry. I want you to divide by something so you can use another identity up here. So maybe divide by cosine squared. Divide everything by cosine squared. Do that. And see what happens. Now, one thing hopefully you pulled from Trig a long time ago is that teacher telling you everything in terms of sine and what? Cosine. Always try to rely on sine and cosine. Always. So that's why I said divide by cosine. Now, since I'm working with squares, I'm going to divide not by cosine, I'm going to divide by what? Cosine squared. So I'm just going to go out here and I'm going to say, I'm going to divide by cosine squared. Now, there is one thing I need to tell y'all. Sometimes I leave off the theta. Okay, when I'm up here and I'm doing work and I'm trying to solve something or I'm trying to manipulate something, I forget the theta. All right, so I'm talking to that person that tells, when I say tomorrow, you say, I don't come to this class tomorrow, I'm talking to you. If I leave off the theta, it's okay, all right? It's not going to end the world, okay? So I don't need you telling me, you left off the theta, shut up. You need to worry about more important things than me leaving off the theta, all right? Let's go ahead and get that out of the way right now. So I'm going to divide by cosine squared theta, and cosine squared theta. Now rewrite that. Well, sine squared over cosine squared is what? I'll do this one for you. That's one. And this one, you could put this as 1 over cosine theta, 1 over squared. And what's 1 over cosine? Wow, look what we got. What is that 1 over cosine? That dang old secant. Yeah. And what is that? So I started with the sine plus cosine and ended up with Another identity.
How did you distribute that again? I see that there's one of the cosine, but then you also added one on the left side. Well, the top you had one on the cosine, but then the second row you had take the plus one, you had another one.
What's cosine of cosine?
Okay.
You wait. You need some. I got some Jack and Coke. I mean some Coke right here. You want some? That's what I would. That's what's y'all missing. Y'all need some daggum Mountain Dews. That water. Throw that water away and drink it at about 11 o'clock. Y'all need to wake the heck up. All right, now I divided by cosine. So what do you think I'm gonna tell you to do next? Divide by the sine. Do it. And what I'm teaching you is, and I don't know if I'm teaching you or not, I don't know if you have a teacher teaching this. Do you have to memorize the identities, or do you just have to learn a couple of identities and use them? You don't have to memorize all the identities. This is manipulation. You're manipulating sine squared plus cosine squared into something else. So now I'm going to take and I'm going to divide by, what did I say, sine squared? Okay. I complimented you, and now you're going to screw me over. I think I locked it down. The arrow won't move. So that's just, okay. Try this again. I don't have any idea what just happened. So sine over sine is 1 plus, what's the cosine over the sine? Look at there. Isn't that neat? And 1 over the sine is what? Oh my gosh. There's another identity. So you can actually take, and instead of memorizing all 3 identities, you can just what? Remember the 1, which is sine squared plus cosine squared is equal to 1. Now, I didn't tell you that you don't have to, you gotta memorize this one and these. You got to. Now you don't have to memorize all of these, you just have to memorize 3 of them. Okay? And that is sine, cosine, and what? Tangent. And the rest of them are what? The reciprocal. That's why they're called the reciprocal identities. So, let's narrow it down. I've told you have to remember these 2, and you have to remember these. So I'm asking you to memorize 5 identities. And if you can memorize those 5 identities, then you pretty much have it flipped. Okay? I wrote my own notes today. Aren't y'all proud? Now, there's also the negative identities that I didn't copy them down. And let me show you those right quick. Let me get out of this and pull up that. These right here. Oops, sorry. Sorry, Miss Kramer. Whoever you are. There we go. And I'm going to pull that in. I'm just going to show you a little trick on these to remember. I'm sorry I have to do all this, but I do it for y'all. I sure don't do it for myself. All right. So let's take an example. Let's do a little bit of algebra review. And remember that when you have one of these guys, that is symmetrical around the what? It's wound around the y-axis, so that's called an even function. And an even function is, the old rule that goes with the even function is f of negative x is equal to f of x. Remember? F of negative x is equal to f of x. And then on the other side of the coin, you've got maybe something like this. The x cubed function, which is around the what? What's it symmetrical around? The origin. Okay? And that's the odd function. Okay? So f of negative x is equal to what? Negative f of x. So take your calculators out. And I want you to graph the sine and the cosine function. Graph them separately, okay? So graph the sine function. No, graph the, graph the cosine function first. And when you graph the cosine function, it's going to look something like that, right? Well, that doesn't look too good. Hold on, let's see if I can fix this. No, it's not going to be. That thing right there, as soon as it comes up, that's when I start having problems. That thing should not be there. No, I thought I could. I guess I can't. I was going to move that, so. Redraw it. Well, y'all get the point. It's symmetrical around the what? It's symmetrical around the origin. So, no, it's not. It's symmetrical around the y-axis. So the cosine function is what? It's the even function. And with the even function, f of negative x is equal to what? F of x. So cosine of negative x is equal to cosine of x. Did y'all see what I did? Did I get this here? See? No, it's chopped off. So what about the even function? Well, what's sine? Well, if you look at sine, sine is going to be around the origin. It starts, and then it comes through the origin, and then it hits at 1. Something like that. So, and it goes like this, So it's symmetrical around the, okay, symmetrical around the what? The origin. So, put it up here. Sine of negative x equals what? Negative sine of x. That looks familiar. Wow, look at that. So do you see how the even and odd identities are set up? Do you have to memorize it? Not really. As long as you have a graphing calculator, you can see where they're symmetrical. All you got to remember is the, what is this called? What did I call that? The what? ALG. What does that stand for? All right, everybody on 3. 1, 2, 3. Y'all want me to turn into Muhammad Ghavati? You want me to be like that? All right, then stop this quiet crap. All right, this is not going to work. All right, Mountain Dew. I don't want to say drink coffee because it makes your breath stink. All right, kind of like the Marlboro Reds do. Okay, all right. So don't breathe on me. If you do both of them, I have relapses of Paris Island, and I don't like that. So don't talk to me when you do both of them. You have to remember the what. If you're going to suck at calculus, it's because you sucked at what? Algebra. 90% of calculus is algebra. You're going to see it here probably. You're going to see a lot of it today when we start with limits. Okay?
What do you plug in to get those graphs?
When you do what?
What do you plug in to get? You said you graph, but I just didn't know how to.
No, just graph the sine of x. Y is equal to the sine of x. Y is equal to cosine of x. Just plug them into your graph. Hold on. Dang old, somewhere on here, dang old virtual calculator. There it is. Well, this computer needs some Mountain Dew too. Dang old, y is equal to, where's the sign? Here's the sign of x. Let's see, dang old graph. There it is. And you see, it's around the origin. And blah, blah, blah. And you can use the reciprocal rules to let your, right here, you know the cosine is tied in with the what? I'm sorry, it's supposed to be all the way. Why is this thing, there we go. The sine is the reciprocal of the what? And look over there. Let's look at the tangent. Let's go and graph the tangent. Because we might be learning something here. Y is equal to tan. I can't find the tangent. There it is. Of x. It's symmetrical around the what? So I bet if we apply that same rule around the origin, I bet that would be tangent of negative x is equal to negative tangent of x. Let's look. Wow. So now you don't have to memorize the reciprocal identities because all you have to be able to do is graph on a calculator, but you do have to memorize the stuff that you learned back in Algebra 1. Very important. Do you see where I'm going with this? Hopefully, I don't want you sitting there with that identity sheet trying to memorize that whole 8.5 by 11. You don't have to, all right? So I'm trying to give you all these secrets or shortcuts. You just have to learn instead of memorize. Now, here's another trick to help you learn. Remember the unit circle? Let's see if I can bring it back up. There's the unit circle. Now, let's say that you're talking about a 30-degree angle right here. And let's say you put a point right there. All right? If I go around the world and come back, or around the unit circle and come back, what is that angle? Well, it's 30 plus what? What's one revolution? Yeah, it's 360, but in radians, that's real world. 2 pi. So I can put plus 2 pi on this second angle. So let's call this the starting point, and we'll color it red. There's the ending point. That red dot represents pi over 6 plus 2 pi, or theta, whatever theta is, can you associate that with every single angle? Yes. So we can say that x can also equal, I'm going to just say theta. Theta can equal theta plus 2 pi. All right. Now, if you take that reasoning right there, and let's take it over to another page. Then I'm going to write cosine of theta. Let me just write it. I can't write it. Cosine of any number is equal to the cosine of theta plus what? 2 pi. And that's one of your identities. Okay? Just like the sine, and you can distribute that, equals the cosine of theta plus the cosine of 2 pi. That's one of your identities. And you can do the sine also. Sine of theta is equal to the sine of theta plus 2 pi. Or the sine of theta plus sine of 2 pi. That's another one of your identities on down the page. Here's something else you can write down as a trick. Now this is one that's on down the page, but it's an easy way to remember. Just remember that when you're dealing with cosine of x plus y, remember when you're dealing with the cosine and you're trying to rewrite it, that the cosine is going to be, everything stays the same as far as the sine, same sign, okay? And it also mixes, it switches. That's a good way to remember. All right, those two things you need to remember. So if I wanted to rewrite the cosine of x plus y in terms of cosine and sine, then I'm going to do sine cosine, sine x, because it switches, sine x, cosine y, plus the sine stays the same, and then you're going to switch it, the cosine of x plus the sine of y. I'm sorry, no, it's not wrong. Yes. Now you'll see this in just a second. I hope these videos are recording because it really bothers me that that little sign is showing up and it doesn't need to show up. Now it's not. There, that sign right there should not be there. Sign. All right, now put in, see, I'm supposed to hit that and it's supposed to work, and when that thing shows up, there. Take a red pen and put a minus here. That sign stays the same, so if you have cosine of x minus y, then what's that over here? Let's change it to a minus. Now sine, I'm just messed up. This is supposed to be the sine. Sine is the one that switches, so I'll change that right there. Sorry, I suck. sine. Okay, so I'm trying to relate that. So I'll do right in red. Cosine doesn't work the same way. Cosine is kind of opposite. It doesn't stay with the same sign, and it doesn't like to mix. All right, so it's kind of segregated. So that means that your whole thing over here is going to be the opposite of this, so that's going to be a minus. And then it's going to be cosine of x, cosine of y, times what? Sine of x, sine of y. So that's a little way to remember that identity. And if that was a negative, since I can't change this over there, it's supposed to flip over here when I hit that. I guess you see I'm getting a little bit irritated. Change that to a negative, and that changes this to a what? Now, I'm going to write one on the board here. Tan of x plus y. Now, what have I told you? Whenever you talk about tangent, I want you to rewrite that as far as the sine and the cosine. Rewrite this like for sine and cosine. In other words, change the tangent into a sine and a cosine. So that's the identity of what? Sine over cosine. So change that. So instead of tangent of x plus y, it's going to be sine of x plus y over what? Cosine of x plus y. Well, we just told you what that is. The sine and the cosine of x plus y. I told you, so rewrite that. What we're going to do is we're going to manipulate and derive the tangent of x plus y in terms of sine and cosine, and then we're going to turn it back into tangent, and you're going to see the other identity show up. So I'll start you off, because I know some of y'all sitting there going, I don't know what you're talking about. Sine of x plus y over the cosine of x plus y. Now I want you to rewrite this in terms of the two identities we just went over. But you should have just wrote those down. So remember, the sine, it likes to stay with the same signs, right? And the cosine goes with the what sign? The opposite sign. The sine likes to mix it up. So that's going to be the cosine of x, sine of y, plus what? The sine of x, cosine of y. And the bottom, remember the cosine don't like to mix. So cosine of x, cosine of y, sine of x, and sine of y. Now we're not done, because I want to, and you can, this can be sine of x, cosine of y, you can have that turned around. Because multiplication and addition are what? Commutative. So you can have sine of y, cosine of x, cosine of x, cosine of y, sine of y. You can have it like that. In fact, that's the way I'll have on my notes. So I'm going to turn it around. Doesn't matter. Sine of x, cosine of y. Sine of x, cosine of y. Is that what I just said? Cosine of x, sine of y? No. Just did it, but I just did it the same way. I want to put the cosine first for some reason. Doesn't matter, but I want to keep my notes straight. Sine of x, cosine of y, and cosine of x. What I had over here, I'm putting over here, so it doesn't matter. Cosine of x, sine of y. Now, I'm going to go through, and this is a complex rational what? Complex rational expression. So I'm going to multiply by something to kind of clean it up. So I'm going to multiply by 1 over cosine of x, cosine of y, over 1 cosine of x, cosine of y. And I want you to distribute these two with those. That's algebra. Just distribute it, and you'll see what happens. So, I'm just going to put a baby step in here. So 1 over cosine x, cosine y, sine x, cosine y, over 1, plus 1 over cosine of x, cosine of y, times cosine of x, sine of y, over 1. All that. 1 over cosine of x, cosine of y, sine of x, cosine of y, over 1. Oh, I'm just dropping the 1. Sorry. This cosine of x, cosine of y, over 1, plus 1 over cosine of x, cosine of y, times sine of x, sine of y, over 1. Now, what happens here? Cosine of y, what do? And what are you left with? Sine of x over cosine of x, which is? So that turns into the tangent of x. I'll do this one for you. Cosine of x over cosine of x, cosine of y, sine of y. That leaves cosines cancel. And that'd be sine of over cosine. And what's sine over cosine? I'm sorry, what? Plus the tangent of x over, and what happens here? You got the cosine of x, cosine of y is what? I mean, over cosine, that's 1. So that turns into a 1 plus sine of x over cosine of x, sine of x over cosine of y. That turns into what? Well, sine of x over cosine of x is the tangent of what? And then the sine of y over cosine of y is the tangent of y. So that turns into 1 plus the tangent of x times the tangent of what? Y. Now what's tangent plus tangent? Or that should be y, shouldn't it? Yeah, y right here. This should be y. I'm sorry. I was going to add it. There we go. And that is what you get when you take tangent of x plus y, you get this guy. Yes?
Maybe 1 minus 1.
Did I not put, yes, you are. Thank you, thank you, thank you. Now, the sign, thank you for bringing that up, because the signs are going to be opposite if you have a minus. If you have a minus right here, let me do a red. Wow, it worked. Minus there turns this into a what? A minus, and this into a plus. Okay, now, with just what you've learned today, that's all 3 of the additive, and I think if you look on your handy dandy sheet, I'll put it back up, hold on. Go to your handy dandy sheet. Thought I pulled it up. There we go. Now I'm looking for them. They're on here somewhere. There we go. That's your sum and difference identities. Again, you take what you know and you plug it into what you know. That's what manipulation and proving these identities are. We'll go to one in just a minute, and I'll show you what I'm talking about. But we just did these right here. There they are. Now, let's do another one. Let's do, well, is everybody finished with that one? Let's go to another one, and with these right here, with these that you learned right here, mark those because you're going to use them on this next problem. Okay? So those that you learned right there, I want you to do sine let me just write it because I can't write that now, so I'm sorry. Sine of 2x. Okay, now it's not working. Okay, somebody tell me what the difference was 5 minutes ago than now. Now we're just not doing anything. I wish I could turn that stupid thing off over there. It irritates me. It about drove me crazy last semester, and I can't remember what they did to fix it. Take that thing off down there, which it pops up whenever it wants to. Sine you know, it would be a whole lot better if the campus was up with me instead of me trying to fight these battles by myself. Sine of 2x. But when you're on a campus of dinosaurs that type the whole email in their subject line because they don't know how to use email, you have to deal with this on your own. All right, do that. First of all, ask yourself, what is 2x? How do you get 2x in algebra? Ask yourself that. How do you get 2x in algebra? You can answer it now.
X times X.
X plus x. So go ahead and do that. Remember, you're not trying to find the sign of x plus x. You're trying to find the sign of 2x. This is called a double angle identity. All right, you're going to derive it yourself using those last two identities and the sign of x plus x. Remember, the sign has two things. It likes to stay the same as the sign. Sign likes to stay the same sign. And in what? It likes to mingle. It likes to mix. All right? So that's going to give you sine of x, cosine of x, plus what? Cosine of x, sine of x. Now you can rewrite those and get sine cosine of x plus sine cosine of x, which is equal to what? I'll rewrite it. Sine x cosine of x plus sine x cosine of x. So the sine of 2x is going to be equal to sine x what? And that's the identity. Now you do the cosine of 2x. Cosine of 2x is going to be a little bit different because cosine don't like to mingle. It's very intolerant. No sneezing in class. That's all right. You got two more. Sneezing 2 more paragraphs. Yeah. Okay, now did y'all see at that time it worked just fine. So somebody tell me what's going on. I mean, I hadn't changed anything. The thing's still there, but now it's working fine. Now it stopped.
Is that
Okay.
what you said, why didn't you screen anything?
No. And plus it was working fine until that phone showed up. And I can't turn it off, so I don't know. It's a conspiracy. We all know whose fault it is. Whose fault is it? It's Bush's fault. All right, so that's cosine of x plus x. And that's equal to, well, we know that it's always the opposite. Cosine is different, so that goes there. And then it likes to stay by itself. Cosine of x plus what? Sine of x, sine of x. So cosine of 2x is equal to cosine squared x minus what? All right? You don't like that. You don't like this. You can write it like that. There's no problem with that. But I want you to take the reciprocal identities and write this two different ways. Take the reciprocal identity, not the reciprocal, yeah, no, the Pythagorean reciprocal, the Pythagorean identities, and rewrite it in terms of cosine and rewrite it in terms of sine. So that means you're going to take one of them out and plug in something. I'll show you the first one. So we know that sine squared plus cosine squared is equal to what? So I could make cosine equal what? 1 minus sine, right? So using our substitution that we learned back in algebra, take that 1 minus sine and plug it in for what? So that'd be 1 minus sine squared x minus sine squared x. And what's minus sine squared minus sine squared? 2 sine squared x. So cosine of 2x is equal to this, or cosine of 2x is equal to what? 1 minus 2 sine. Huh? Now, do the other way. Solve it for cosine. Solve that over there for sine, and see what you get. Sine squared is equal to what? And plug that in. And see what you get. So that's going to give you, instead of sine, you're going to put 1 minus cosine in there, right in here, and that's going to be, I'll just write it, cosine squared x minus parentheses 1 minus cosine squared x, and then that's going to be cosine of x, cosine squared x minus 1 plus cosine squared of x. So cosine of 2x is equal to what? 2 cosine what? Minus 1. Now let's look back at our sheet. Look back at our handy dandy. I'll bring it back for those that haven't moved down yet. Go back to our handy dandy trig identity sheet. And which one did we do? No, we used the Pythagorean, but which one did we get? It's a miracle. So, with just these 3 sets right here, we've been able to, in this set, we've been able to do the double angle, and we've been able to do the sum and difference. Now, what you need to do now is think about what would you do with this one, and what would you do with this one. I mean, just think about it. You could actually derive those. We're not going to do that because I covered the basics. These, I'll tell you, these are a little bit difficult to, to derive from off the cuff. But the ones that I did today are the ones that you can kind of meander through if you know this one, and this one. Now, proving should not, and we did these two. I forgot we did these two. So with these three, we did 1, 2, 3 sets of identities, just knowing these three right here. And the whole point that I'm trying to, get across to you is that you don't have to memorize all of the identities. You just have to memorize a few, and they fall into others. Now, when you use these, we're going to be proving. Now, I don't know, is there a homework question in the algebra and trig review about proving? Have y'all done any of the homework? There's not one. There should be. Okay, we need to put that in there. Well, hold up just a minute. And I will go up and pull up one. If I could get through with all this stuff, it's like a rat in a maze. All right, let's go back to trig. I just see. Where's my grade book? There it is. All right, now I don't know how to get out of this. There we go. Let me go to trig review. Let's see. There's a trig review right there, isn't it? There's not a prove in there. I'm looking. Okay. Hold on just a second. I'll go to, I have to look and see. How's the best way to do this? I can go to all. Let me go to all. Let's see if there's another trig review. It's not going to do that. Okay, let me go to the book. Trig D. Give me a second. I'll find one. Y'all didn't even know this was in here, did you? Here's your handy dandy notes right there. This is in the appendix part of your book. All right, here's one. Let's do something simple. Let's do number 45, and before you start hollering, I can't see. Hold on a minute. That's the first thing that comes out of y'all's mouth, especially the ones that can't see that like to sit in the back of the room. That's one thing that I've noticed. People that can't see usually sit in the back of the room. And who's the first one to complain? Them. Try 45. It's pretty simple. I'm going to pull a couple of these out using my snippet tool that went away. just pull. I'm just going to pull all these out right here. I have no idea how entailed they are. But here's a handy dandy whiteboard. And while I'm at it, I'll go ahead and pull in our basics. All right, so let's do the first one, and I'm just going to go through and do, where'd it go? It covered up, there it is. All right. And the first one is, well, I'm going to wait a
And it's sine theta.
Thank you. Sine theta, cotangent theta equals cosine theta. So you want to prove this right here. So you got to rewrite this. This one's okay. Sine theta over 1 times cotangent. Boom, you know, reciprocal identity. You know it's a reciprocal identity because you don't know anything about the cotangent. So, what is the cotangent? It's the 1 over the what? Tangent. So 1 over the tangent. Well, that'll help us work the flip. So we look at the tangent and we go, tangent is equal to what? Sine over cosine. So sine theta over 1 times 1 over the sine over the what? Sine over the cosine. Now, anytime we divide by a fraction, we multiply by what? Reciprocal. So that'll be sine of theta over 1 times cosine over what? And what happens? And you get cosine. Now I want you to tell me something. We changed this here and here, but after that it was just algebra. You're going to start seeing more algebra creep in and less calculus, less trig. It's going to be more algebra. So let's do another one. Let's do, let's do, maybe I think it's like, yeah, I think we got enough time. Go ahead and do tangent. Tangent squared, whatever, alpha minus sine squared alpha is equal to tangent squared alpha times sine squared alpha. Now remember, the first thing you're going to do is change that tangent into something else. That's what I would do. That works fine now. Well, what I say, tangent squared minus sine squared. I want to make that equal to tangent squared sine squared. Well, technically you could change this tangent into what? Sine squared over what? Sine squared over cosine squared minus sine squared over 1. Now we got a fraction there. Back in pre-algebra, you learned, in basic math, you learned that if you wanted to add or subtract fractions, you got to have a what? Common denominator. So cosine squared is common denominator. Now, cosine squared, we're going to cosine squared one time sine is sine. 1, we're going to cosine squared times cosine squared times sine squared is cosine squared sine squared. So now we've got, I have no idea if this is the way we need to go, but I'm doing it that way. Sine squared minus cosine squared sine squared over cosine squared, right? That's what I've got so far. I'm looking to see how I'm supposed to make this work. I don't know. Looks like we can factor out a what? A sine. A sine squared, factor out a common term. So sine squared, and that's going to leave you with what? 1 minus what? Cosine squared. Hey, wait a minute. I remember 1 minus cosine squared or something. Cosine squared. What's 1 minus cosine squared? Huh? Sine squared? So that's going to give us sine squared times what? Sine squared over cosine squared. And they want you to write it in terms of the tangent, so you can probably turn that cosine back into a tangent now, because they're going to want you to do that. So go ahead and do that. You could have turned it into, I guess it's okay right here. So cosine is equal to what? Cosine is equal to 1 over secant. That's not going to work. But we can turn cosine squared, or sine, maybe sine to the fourth. I think somewhere we should have turned something back into the tangent. Somewhere. There we go. What's sine squared? Sine squared or cosine squared? Sine squared or cosine squared is what? That's the tangent, right? Yeah. Right here is where we should have done it. I'm thinking that's the tangent right here. No, that shouldn't be it. That's going to be sine to the fourth, which is not going to help us. Go ahead, what'd you say?
Well, I think the left side of it.
Yes, we're trying to manipulate it to make the tangent on the right side.
So then you should just say, right there, there's a sine squared times 1 minus cosine squared over cosine squared, just change it to tan squared times 1 minus cosine squared.
Yeah, that's what we should have done. Talking about right here.
Yeah.
Yeah, we could have done that, but that would give us.
It would equal the same thing.
Yeah. That would be the same thing on the right side. That'd be this. Right here.
Well, you changed 1 minus cosine squared.
Yeah. 1 minus cosine squared is the 1 minus cosine squared is sine squared. You saying distribute it?
No, I'm saying take sine squared over cosine squared, change that to tangent squared, and then change the 1 minus cosine squared to sine squared. So that's tangent squared minus sine squared.
Yeah, that's where we messed up. You're right, I think. Okay, in other words, sine squared, and this is, but this is over 1 denominator, I'm thinking. If that's possible. No, you can't do that. You can't do that because that, you can't, this is 1 denominator. So you can't put this over this. Yeah, you can. Yeah, you can. So that would be tangent. And then this is 1 minus cosine squared is 1 minus sine squared, and that's sine over cosine, which is tangent. But that still would not give us tangent sine squared, would it? I don't think it would. No, because then you still got sine or cosine right here. I'm thinking, you know what I'm thinking? I'm thinking that we could change this cosine squared into 1 minus the sine squared, right? Could we do that? 1 minus the sine squared? No, still going to give us sine squared times sine squared, no matter how you do it. So we must have went wrong somewhere. Anybody see? We went wrong somewhere. And usually when you go wrong on one of these, you have to go back and do something different. Just do something different. Yep. I'm looking to make sure I didn't copy anything down on tangent squared minus sine squared is equal to tangent squared sine squared.
Also, why we confuse the sine squared times sine squared with cosine squared times tangent squared times sine squared.
If you do, you can do it all day, but it's not going to give you this. Sine squared over cosine squared times 1 minus cosine squared over cosine squared. This, what's sine over cosine? Tangent. And what's all this? This is 1 minus cosine. 1 minus cosine is equal to sine. Sine over cosine is equal to what? Tangent. Tangent times tangent is going to give you tangent to the fourth. That's not going to work. At least I don't think it will. All right, any other suggestions? Well, I think we've got to go back and do something different. Now, we changed this into sine squared over cosine squared. This, I hear whispering. What do you think we should do?
I was just confused.
What? Where are you confused?
If you change the sine squared over cosine squared to tangent squared, doesn't that take away the denominator?
Yeah, the whole thing's over the denominator. So 2x, well, no, wait a minute. 2x over 2. Yes, you can. Well, you can do that, yes. But still, let's see. You're right. Yes, you are right. You can do that. That's right. So that would be, you're right. I think you're right. Cosine squared over sine squared would be tangent squared. I was looking at it as common denominator. Tangent squared, theta. And then 1 minus cosine is what? Sine squared. Good job. You're right. You're right. Now everybody should be saying, now everybody should say, oh yeah, that's what I did. That's what I was thinking. Okay. Okay, go back to your pre-algebra. What if you have 4x over 2? Okay, what did you do? You use that denominator here and here. This is multiplication, right? All right, what's here? What's this? Multiplication. This is 4 over 2 right here. Now, back in your algebra, did you use that 2? Well, that denominator was 2 for here too, but you used it. You see what I'm saying? Why I said it couldn't happen is I was thinking of this as a what? I was thinking of that as a plus, and that's why I was thinking it was a common denominator. It wasn't. So this is multiplication. So I basically made this the 4 and this the 2, and I made that combined. You see your algebra? Always go back to your algebra. Always. You're right. Okay, so that equals the tangent squared. Where is it? Tangent squared, sine squared. Here it is right there. All right, now, what you need to do is take a picture of this or whatever, and write these down and work on some of these at home, and we'll do them when y'all come back, whenever day y'all come back. All right, I don't know what time it is right now.
Tomorrow, right?
Yeah, tomorrow, which will be Tuesday, right? I don't know what today is. Today is Tuesday, so that means Thursday. Okay. It's 9:43. We got time to do a couple of more things, and the only thing I want to do is start talking about limits. Okay. I need to start talking about limits because y'all need to start getting into limits. So write these down and just work on them. If you can do these, you can pretty much handle whatever we're going to do with calculus. Don't fret too much on the identities because we're not going to spend much time on the identities as far as algebra, as far as calculus. The first thing we're going to be doing in calculus is the limits. Then we're going to be moving into calculus. We're not going to be revisiting into the identities until later. All right, so don't fret over these if you can't do them just like this. It's not a big deal. Okay? I'm going to move on to some identities. Now, right now, we've done 2 or 3 things. I'll put this back up if you need me to. That's class. One, we reviewed over algebra. Okay, one we reviewed over algebra. The reason we reviewed over algebra is because algebra is everything to do with calculus. Now, I'm going to show you the limit. And the limit theorem and all that good stuff. I'm not going to go through the theorem, but the whole point is you understand what the limit. These two together give us calculus. Now, that's why I'm not worried about the identities right now. The limit theorem is basically a way of thinking. Limits are a way of thinking. Is it the way of thinking that you don't think that you use every day? No, it's not. That's why it's so difficult for people to understand what calculus is. The way of thinking of a limit is this. If I decide to walk toward a wall, but every step toward the wall is half my previous step. Will I reach the wall? Okay, so that's the thinking of you. So let's say that I'm wanting to walk toward that wall and I have a stride, and the reason I'm going to use 4 feet because I don't have a stride of 4 feet, but I'm going to say 4 feet because of mathematical purposes. My first step toward the wall is 4 feet. Everybody with me? Now the stipulation is for the limit that I take half my previous step. So my second step would be what?
2.
Third step? 4th step? 1/2 foot, or 6 inches. Then what? 1/4 of a foot? 1/8 of a foot? 1/16 of a foot? 32nd of a foot? 64th of a foot? 1/28th of a foot? And so on. Will I ever reach the wall? Doesn't matter. You never will. Mathematically, you never will touch the wall. Think about it. What? Good job. That's exactly what you're supposed to say. You'll get right up to it, but you never will what? Now let that sink in for a minute, because that is very important. You never will reach the wall. Mathematically, you never will reach it. You can start with a 6-foot stride. You never will reach it. This is called convergence. Okay? Convergence. I guess that's the most spelling. Converging. Unspell converging. Converging is when you get up to something, but you never ever touch it. Now, what in the heck does that have to do with the calculus? What? Doesn't matter. Well, no, that would defeat the purpose. I mean, that would defeat the purpose. We're not gonna take one step. You're converging toward the wall. That means you are traveling toward the wall. Okay, you never will reach it. Okay. Yes, you're working with me. Most people are working with me. Exactly, you're taking half of a half. What is happening to the denominator? It's getting bigger, and if the denominator is getting infinitely bigger, the fraction is getting infinitely what? Smaller. You're converging onto a wall, and you're never touching. Okay? You're not changing the wording and saying, okay, if I decide to walk toward a 4-foot wall, 4 foot away, I didn't say anything about a 4 foot away. I didn't say 2 foot away. I'm assuming that you're far away from a wall. Okay? Maybe I need to put that in there.
Is that right? Because maybe once the fraction is so small, it just regressive?
No, you're just not going to reach the wall. So you see, some of y'all are having a problem with this. Okay? You're not thinking infinitely. All right? Think infinitely. What? Okay, do this. If you can't get this, tell me. Let's just pull over to the side here. Got a ruler, and this is 0 feet. This is 1 feet, 1 foot, 2 foot. I want y'all to tell me how many numbers are in between 0 and 1 foot. Good job. I got 3 people. I heard 3 people. Said infinite. If you're sitting there going, there ain't no numbers in between 0 and 1, then you might want to think about dropping the course. Okay? Because how many numbers? Well, there's a half, there's 3/4, there's 0.33, there's 0.03, there's 0.003, there's 0.0003, there's 0.001, 0.0015, 0.0016, 0.0017. You get up, you following me? You have to think, the old way of algebra is, I'm going to find me a point. Okay? And you find a point. You find a point on a number line. You find a point on a Cartesian coordinate system. Bang! I found me a point. I got the answer. And you've done that for how many years? Algebra 1, pre-algebra, algebra 1, algebra 2. For 3 years you've done it. And then all of a sudden, bam, somebody turns around to you and says, okay, take half of a half of a half and converge it. What? What's convergent? Well, you take, how many numbers you got here? There ain't no numbers there. I'm looking for a point. I've been doing a point for 3 years. You see what I'm getting at? They're changing they're changing horses in midstream on you. You're used to doing 3 years of give me a point, give me a point, give me a point, and then they switch horses on you in midstream and they say, okay, this is infinity. We're in infinity. You ever seen Ant-Man? Squirrel! I'm sorry. I've switched gears on you. You ever seen Ant-Man? What happens when Ant-Man hits the button too many times and he goes into whatever? Yeah. Now think about it. If you split an atom and you split an atom and you split another atom, can you keep splitting that atom? Yes. You can keep going and going and going. And then you get past what we think is real. And you get into a non-real world to us, but it's there. There's a world there. It's kind of like that dang old, if I have to bring it down a little bit, dang old Dr. Seuss, the elephant with the flower. There's a world on that flower, okay? Now, that's fairy tale stuff, but if you split an atom and split an atom and split an atom and keep splitting that atom, there is an atom there. Even though we can't see it, there is there. You don't see these numbers. They're there. So, you can either do this. You can say, okay, I learned to find a point. This is stupid. I'm not going to learn it. You're going to flunk algebra. You're going to flunk calculus. Okay? So, it's either you're going to be stupid and flunk calculus, or you're going to work with me and you say, okay, I understand convergence. I understand that if I take a half step, I may get close to this wall because I can't take the half of a half of a half of a half of a unit from my feet. Okay? You're thinking in algebra world then. But if you think of convergence, then you're thinking in the infinity. There's an infinite amount of numbers here, and there's an infinite amount of numbers here. Now, what the heck does that have to do with calculus? Well, we're going to study limits here for the next day or two. But after we study limits, we're going to put the two together. And when we put the two together with this stupid board that won't work, I'm starting to get angry. We're going to take the two and put them together. What I mean? Well, back in algebra, you learned how to find the slope, right? Dang old. And this is x of 1, y sub 1. This is x of 2, y sub 2. And you said the slope is equal to y sub 2 minus y sub 1 over x of 2 minus x of 1. Everybody remember that? You were finding a slope. One slope. Didn't have anything to do with infinity, didn't have anything to do with anything. It's just a number. I got the number, I got it right. Did that for 3 years. Now, you're going to apply the limit theorem, and that same slope that you learned right here, there's that slope right there, is the secant line. The secant line goes to the interior of the curve. Now, somewhere in algebra and pre-algebra, you learned that this was redneck, and you needed to change it to f of x. Remember that? You had to change everything to f of x, so you sounded smart. So, this point is x. I don't know what that is. And this point is not y anymore because it's redneck. What is it? F of x. This point, then this distance right here, is h. We'll call it h. This is x plus h. And this is f of x plus h. Okay? Now, we're still in algebra. If I want to find the slope of that line, I do y sub 2, which is this right here, f of x plus h, minus f of x over x minus x plus h. X minus x plus h, which gives me f of x plus h minus f of x plus over h. That's called the difference quotient. We're still in algebra. But when we apply the limit theorem, I'm going to bring this dot down. How many numbers are between 0 and 1? Take half of a half of a half of a step. What am I going to do to the wall? What's the C word? I'm going to converge on it. And I get, let's use the width of a hair. Okay, we'll use the width of a hair for, I'm going to get this dot within a width of, let's do the blue dot. Let's do red dot. Okay, there's a width of a hair between those two. And using the limit theorem of the dots, see all those dots? Half a step, half a step, half a step, half a step, half a step. I get within a half of a hair of this black line. That secant line turns into a tangent. And that's what we're going to learn when we put algebra with the limit theorem, put them together, and then you get limit as h approaches 0. And that's called the derivative. Okay? So that's where we're headed. So just stick with me the next couple of days, which would mean Thursday and Tuesday. And by Tuesday, we'll be doing the difference quotient right here. And then I'll show you the derivative, and then the whole world is just going to open up and you're going to say, I understand. And then you're going to get mad because some of you have taken this class 2 or 3 times, and it's really that simple. All right, let me get the roll right quick. Now, I realize that I'm gone. No, I've got 2 minutes left, so y'all can sit down and not be rude. Okay? Or don't try to walk out. I got 2 minutes. Let me shut off the do-jigger. I hope this does right. I hope this